Alright, so in this video we're going to review translating a sentence into a one-step equation. We did this back in chapter 1.1, so we can always review that graphic that we have on there, and I'll pop that up here in just a second. And we're also going to choose some stories that can be represented by a given one-step equation. So they're going to give us an equation, we actually have to think of a story that goes with those numbers. So first, for translating a sentence, one of the big pieces here is that we do want to remember, we wrote this one out in section 1.1 on the notes page. There are definitely more than these words, but these are kind of the most common words that we're going to be using. And I circled sum, difference, quotient, and product, if you remember from that video or lesson, because those are kind of the more, not most common, I don't know if I want to say that, but they're very, very commonly used because it means the answer of that type of problem. So if you hear sum, it means the answer of an addition problem, or it means that the next two pieces are going to be added. Usually it's two pieces, that's why I'm saying that. Difference means subtract, quotient means divide, product means to multiply. So we also have a lot of other words in here, subtracted, subtraction, minus, less than, decreased by, for this is all in the subtraction little symbol. For addition, we have addition, added to, add, plus, more than, increased by. For divide, we have divide, divided by, or quotient. Those are pretty much what they're going to use for those words. And for multiply, we have multiply, multiplication, multiplied by, times, product, just the word of, just that simple two-letter word, excuse me, or the words twice or triple. So this not only tells me what I'm multiplying by, or that I'm multiplying, but what I'm multiplying by. So I'm not just going to multiply by anything. Twice means times 2, and triple means times 3. So we just want to be aware of those words while we're translating. So let's go back really quick. We're going to look at this one. So we have 153, so hopefully it's pretty straightforward. The only thing that's not on that graphic, which it wasn't on there the first time we did it either, is the word is. Anytime you hear the word is, it means equals. So 153 is the product. So product means, if we were paying attention to that graphic there, product means to multiply. So I can see it there. So let's go back. So we're going to multiply, but we're not just going to multiply anything. We're going to multiply the next couple of pieces, because product means the multiplication of the next given terms. So 9 and Ricky's savings, and they want us to use R for Ricky's savings. So I have Ricky's savings, and I have 9, and I want to make sure that I multiply. So the times doesn't really want to go out in front there. I want to multiply the next two pieces, which were 9 and R. So my little equation is going to be 153 equals, instead of 9 XR, we do not want to use a little x for product or for multiplication. We would probably use a dot, although since it's a number and a variable, I can just smush them together like this. This means 9 times R. Alright, let's look at the second one. We have Hector's age. So this is something, Hector's age, and then if I look down here, they want me to use H for Hector's age. Increased by, so increased by, this is my my operator. This is telling me what to do. So if I go back over there, that increased by was on that list. So if I look through and I can say, here's decreased by, here's increased by, so they want me to use addition. So I'm going to increase it by, I'm going to add 17. Is means equals, and then 75. So I have H plus 17 equals 75, and then I'm all done with that one. So they're not asking me to solve it yet. They don't want me to know, like they don't want me to figure out what R is or what H is. They're just asking me to write the equation. All right, down here, so we have each equation below is followed by several stories. Select all of the stories that can be represented by the equation. If none of the stories can be represented, select none of the above. All right, so we have 3x equals 12. And we have to think of what this means. So before we start reading the stories, I want to come down here and I want to think about it. What is happening in this equation? 3x means 3 times something. So we're multiplying by 3. I don't know what it is. X is a something. Not really sure what it is yet. Equals 12 means that the total is 12. So I'm multiplying something by 3, and then I'm going to get a total of 12. So those are the words that I want to look for when I'm looking at my stories. So Eliza and her friend have a combined total of 12 cards. So total of 12, that works, because that's the total. Eliza has X cards and her friend has 3 cards. So with this one, if they have a combined total, and Eliza has X and her friend has 3, this isn't asking me to multiply. This would be asking me to add. So this one does not work. That's not a good story. Eliza has 12 friends, so that sounds like kind of a total there. Each friend gave her X cards. This gave Eliza 3 cards. That's kind of interesting. If she has 12 friends and each one gave her a card, even if they only gave her 1 card, how does she only have 3? She had negative cards. So this would also be something along the lines of each friend giving her a card. But in this case, this isn't the total. So I was kind of reading that to begin with and said, oh, 12 friends, that sounds like a total. But actually the total is she has 3 cards. So if she has 12 friends and each one gives her a card, they are asking for multiplication, but they're asking for multiplication for the wrong numbers, because this is how it is. So in this case, each friend would have had to give her a quarter of a card, right, in order for this to work. So they did not give her a whole card each. Interesting. All right. So this one doesn't work. It is multiplication, but it's not multiplying the correct pieces. So Eliza has 3 packs of cards. Each pack has X cards. Eliza has 12 cards. Ooh, this one sounds a little bit better, because now I have 3 packs of cards. So packs hold a certain number of cards. Well, each is a multiplication word, has X cards. So 3 packs and each one has X cards, and she has a total of 12. So this one works. This is a check mark. I guess I'll put a check mark instead of an X on that one. So this story does work. So there were X cards in a pack. All right, so we have so many cards in a pack. And Eliza took 3 of the cards. There are 12 cards left in the pack. So there were this many in the pack. She took 3. That means we're taking them away. We're subtracting them away. And now she has a total of 12. So this one does not work because it's subtraction instead of multiplication. All right, so now let's look at the second example here. We have X plus 11 equals 88. So same thing. Let's think about it before we just start reading the stories. So we're going to go down here to the bottom and say what's happening in this equation. So X plus 11 means 11 added to something. So I'm looking for addition in this one. I want whatever it is, whatever that something is, I want to go 11 more than that. I want to add to it. 8 equals 88 means the total needs to be 88. So those are the pieces that we need to look for. We're adding 11 to something, and our total needs to be 88. So we have Frank is X years old. Eliza is 11 years older than Frank, and Eliza is 88 years old. So Eliza is our total. Her years are 88. Frank is X years old, and she's 11 years older than him. So if I want to know how old she is, if I know how old Frank is, I'm going to add 11 to that, and that'll tell me how old Eliza is, which is 88. So this would actually be an equation to figure out how old Frank is, because I'd want to kind of go backwards to figure that out, since I already know how old Eliza is. But this works, because I'm adding 11 to Frank's age to get 88. Frank is X years old, and 11 years ago, he was 88 years old. So with this one, this would be, here he is now, and if I subtract 11 from that, because it's 11 years ago, it's in the past, he was 88. So we have the correct total, but we're not having the correct operator here, so this one does not work. Eliza is X years old. In 11 more years, she will be 88 years old. So right now, she's this old. 11 more years. So I'm going to add 11 to that, and I'm going to get 88, because that's her total here. So this one also works. All right, Eliza is X years old. So we know how old Eliza is. Frank is 11 years younger than Eliza. So he's younger than X, 11 years younger than that. And he is 88. So the correct total again, but the wrong operator. So this one does not work. All right, so that was translating sentences into one-step equations and choosing stories that can be represented by a given one-step equation. Sometimes if we stop and we kind of slow down and say, okay, what's happening in this equation? How can I explain this to myself? You know, what do the pieces actually mean? It makes it much easier to understand what's going on within the equation. So go ahead and give that a try on Alex.